Okay, so let's use volume and density to solve problems. A kilogram by any other name. Which has more mass, 1,000 kilograms of feathers or 1,000 kilograms of steel? Explain your reasoning. Well, mass, as long as you are on planet Earth, mass will be exactly like weight. So how much something weighs. The mass only changes if you leave planet Earth. Like if you go to the moon or you go to a different planet where there's different gravitational forces at play. But as long as you're on planet Earth, mass is going to be the same thing as weight. So if that's true, well, 1,000 kilograms of feathers, 1,000 kilograms is feathers versus 1,000 kilograms of steel. So they will be the same. Because they are both 1,000 kilograms. All right, first question. It's just like kind of a tricky one. Feathers versus steel. You might think, oh, it's steel because it's like much more dense. But we're gonna get into density here in a second. So density is next. All right, 17.1 down. Okay, the feathers in a pillow have a total mass of 59 grams. Okay, so up here, mass equals 59 grams. Okay, the pillow is in the shape of a rectangular prism. All right, so you got your pillow in the shape of a rectangular prism. Okay. This is a pillow. Okay, the measurements are 51 by 66 by 7. So 66, 7, and 51 centimeters. Now, what you need to know for this is that, well, let's get into this first. Volume equals 51 times 66 times 7, right? Hey, Claire, grab me a calculator, yeah? Thanks. Because this is length times width times height. Thank you. 51 times 66 times 7 is 23,562 centimeters cubed, cubic centimeters. Okay. Got that? Steel anchor is shaped like a square pyramid, okay? So let's draw a square pyramid. Start with the base, and you draw an apex. Connect each vertex to the apex. All right. Each side of the base measures 20 centimeters. And the height over here is 28. The mass equals 30 kilograms. Okay? So the first thing I'm going to do is calculate the volume of the pyramid. So the volume of the pyramid is going to be base times height divided by 3. Because it does have an apex right here. So your base is 20 by 20, right? Your height is 28, and you got to divide that by 3. So 400 times 28 divided by 3. 400 times 28 divided by 3. 3,733.33 centimeters to the third power. That's our volume of this steel anchor, right? So this is the anchor. This is the pillow. All right, so now that we've answered all that, we can start attacking this problem. Now, the first question is, what is the density of feathers in kilograms per cubic meter? All right. Tough question. There's a lot of things at play. Let's talk about density here. Density equals mass divided by volume. Now, our mass is in grams. They're asking for kilograms. Our volume is in cubic centimeters, and they are asking for cubic meters. So first you got to change grams to kilograms. Now, 1 kilogram equals 1,000 grams. So if you have 59 grams, what will that equal in kilograms? So you go 1 to 1,000 equals X to 59. Cross multiply. 1,000x equals 59. X equals 59 divided by 1,000. 59 divided by 1,000. So 59 grams equals 0.059 kilograms. Okay? Now up here, you know your volume is 23,562 cubic centimeters, right? But they ask in cubic meters. So 1 cubic meter equals 1,000,000 cubic centimeters. So you got to go like this. 1 over 1,000,000 equals, these are the cubic centimeters right here, x over 23,562. And then you cross multiply. You're going to get 23,562 equals 1 million times x. Divide both by 1 mil. It'll cross out, so you're going to get x equals this divided by this. 23562 divided by 1, 1, 2, 3, 1, 2, 3. And you're going to get that 23,562 centimeters cubed is the same thing as 0.023562 cubic meters. So, kilograms, cubic meters. This is your mass. This is your volume in the right measurements. So your density is 0.059 kilograms divided by 0.023562 cubic meters. So 0.059 divided by 0.02356 equals 2.5. Now what do you say? You say the density of feathers in kilograms per cubic meter is 2.5. Tough problem. All right, I'm gonna move this little device over a tiny bit. I'm noticing every time my arm moves, it shakes this thing a little bit. So let me move this over, and then we'll keep going. All right. What is the density of steel in kilograms per cubic meter? Okay. So, density, keyword, equals mass divided by volume. We already determined our mass was 30 kilograms. So mass equals 30 kilograms, which is what we need, per cubic meter. And we've got centimeters. All right? So volume equals this, but we need to change this to cubic meters. So remember, 1 cubic meter is the same as 1 million cubic centimeters. 1 cubic meter is the same as 1 million cubic centimeters. And our volume is in cubic centimeters, 3733.33. So you just write 3733.33 over x. And that's how we're going to figure out what it is in cubic meters. So then you cross multiply. You're going to get 1,000,000 x equals 1 times that is 3733.33. Divide both by 1,000,000. These cancel out, so x will equal this divided by this. 3733.33 divided by 1,123,123 equals 0.003733, and that is cubic meters. All right, so volume equals 0.003733 cubic meters. Now, you gotta do mass divided by volume to find density. So you just go 30 divided by this. So 30 divided by 0.003733, and you will get density equals 8,036.4 kilograms per cubic meter. That's your final answer. Ooh, tough problems out of nowhere. They throw you these tough ones. It's okay. I just want to teach you what density is. Density is basically like, well, it's mass divided by a volume, but it's the amount of it's the amount of mass in a certain volume. So like, I don't know if it could even handle it, but yeah, look at this. This is like, this tape dispenser, it's full of sand, right? Versus like this pencil holder, which is just like a hollow. This is really light. This is really light. This is really heavy. So this is much more dense than this, even though they have almost the same volume. Okay. All right, what is the volume of 1,000 kilograms of feathers in cubic meters? Okay, the volume of 1,000 kilograms of feathers in cubic meters. Let's see here. So, because we know that the density of feathers in kilograms per cubic meter is 2.5. So we have 2.5 kilograms for every 1 cubic meter. What would 1,000 kilograms be in cubic meters? So we're gonna call that X. And all you gotta do is cross multiply and solve for X. So you're gonna get 2.5x equals 1,000. Divide by 2.5, divide by 2.5. X equals 1,000 divided by 2.5. 1,123 divided by 2.5. You're gonna get 400 and what was it? Cubic meters? 400 cubic meters. So you could say the volume of 1,000 kilograms of feathers is 400 cubic meters. Eesh. Okay, what's the volume of 1,000 kilograms of steel in cubic meters? Well, we determined that there's 8,036.4 kilograms in 1 cubic meter. So we're gonna say 1,000 over x. And this is cubic meters. Cross multiply. X times 8036.4. You're gonna have 8036.4 times x equals 1,000 times 1 is 1,000. Divide both by this. These cancel out. X equals 1,000 divided by 8036.4. So 1,000 divided by 8036.4. You're gonna get 0.1244. Just keeps going. So the volume of 1,000 kilograms of steel in cubic meters is 0.1244. So let's write it out. The volume of 1,000 kilograms of steel is 0.12 cubic meters. Eesh. Yeesh. 17.2 is a beast. Alright, it's okay. It's no big deal. It's just math. Even if you don't understand this, you will be fine. Don't sweat it. Alright, here we go. 17.3, a fishy situation. An aquarium manager drew a blueprint for a cylindrical fish tank. Okay, so here's your cylindrical fish tank. The tank has a vertical tube in the middle, which visitors can stand and view the fish. All right, so visitors are like standing here in the middle, basically. The best average density for the species of fish that will go in the tank is 16 fish per 100 gallons of water. Don't write on my board, please. So 16 fish per 100 gallons of water. So this is the ideal density. This provides enough room for the fish to swim while making sure that there are plenty of fish for people to see. The aquarium has 275 fish. So 275 fish are in stock. Is this the right number of fish for the tank? If not, how many fish should be added or removed? Explain your reasoning. All right, so first thought is let's get the volume of the fish tank. So the volume of the fish tank is gonna be, it's gonna be the whole thing minus the middle. So you've got a 3 plus a 2, meaning that the big cylinder has a radius of 5, because this is 2, right? So that's 2. So the whole thing for the big one is 5. Then we're gonna subtract the small cylinder, which has a radius of 2. So big cylinder minus small cylinder. We're gonna get the volume. So find the volume. And the volume of the fish tank. All right, so big cylinder radius equals 5. Small cylinder radius equals 2. Big cylinder height is 4. And small cylinder height is also 4. So let's go to our formula. So volume equals pi r squared times height. Volume equals pi r squared times height. These are cylinder formulas for volume. Pi r squared because the base is a circle. So this one is pi 5 squared times 4, which equals 25 pi times 4, which equals 100 pi. Okay, that's the big cylinder. This one is pi 2 squared times 4, which equals 4 pi times 4, which equals 16 pi. Now we gotta go big minus small. So 100 pi minus 16 pi equals 84 pi. And that equals the volume of the fish tank. All right, so number 1 is down. We're done with the volume of the fish tank. Okay. Now, they say, so take your givens. Write them down. They say that there's 16 fish. The ideal density is 16 fish per 100 gallons of water. H2O is just the chemical symbol for water. So 16 fish for every 100 gallons of water. Okay. Well, you need to know something. You need to know this. There are 7.48 gallons of water in a cubic foot. Okay, and we have 84 pi cubic feet of volume. So 84 times pi equals 263.89 cubic feet, right? That's our volume of the fish tank. Now, if there are 7.48 gallons per 1 cubic foot, well then how many gallons are in 263.89 cubic feet? That's what you gotta figure out. So we just cross multiply again. So 263.89 times 7.48 is 1973.9. X times 1 is just X. So X equals 1,973.9 gallons of water. In the fish tank. So we got 1,973.9 gallons of water in the fish tank. They said 16 fish for every 100. So you say 16 over 100. That's fish. for every 100 gallons. Well, what about for 1,973.9 gallons? How many fish, right? Cross multiply. You're gonna get 31,582.8 equals 100x. Divide by 100. Divide by 100. X equals that number divided by 100. 315.82 fish. Remember? Fish. So let's just round that up to 316 fish for that fish tank. So you want 316 fish in this fish tank. Remember, you've already got 275 fish. Is this the right number of fish for the tank? No. The right number is 316 rounded to the nearest fish. How many fish should be added or removed? Since we already have 275 fish, we should buy 316 minus 275, 41 fish, and put all 316 in the tank. Oh my, what a problem. Again, if you do not understand this, it's going to be okay. All right? But one of the hardest problems you'll ever see in the illustrative math high school geometry curriculum. But you need to get 41 more fish and then put all 316 in this tank. All right, have a good one. Do the practice problems. Density, that's the big one. I'll write it real quick. Density equals mass divided by volume. That's the key principle. As long as you stay on planet Earth, mass is the same thing as weight. Mass is a function of gravity. So if you change the gravitational pull, it'll change your mass. So like the mass of this tape dispenser will change if you go to outer space. However, as long as you stay on Earth, the mass doesn't change. So you astronauts, just remember, mass will only change if you fly to outer space. All right. I'm tired after that. Yeesh.